Hi everyone, welcome to the final lecture. Thanks for coming. I know that everyone's so busy with assignments and not just for this course, for all your courses. So as always, there's a link to the live lecture code that you can find. If you haven't done your My Experience surveys, this is just a reminder, it'd be great if you could give some helpful feedback for the course. And this is an announcement from the exam team. So this is very, very important. Don't forget to bring your student ID card to the final exam. So bring your student ID card. Make sure you know where it is, so you're not rushing around in the morning unable to find it. But you've got to display your UNSW ID on your desk for the whole duration of the exam. If you don't have an ID card or you don't have it with you, you can provide other official photo ID like a driver's license or a passport, but electronic versions won't be accepted. If your name has changed or the card has expired on your actual ID card, or you've lost it or damaged it, please book in an appointment with the Nucleus Hub to get a replacement. Okay, and this is all part of the official UNSW rules. So this, isn't just us making this up for our exam. This is going to be for all your exams. From 26 T1, you'll have to have valid student cards. All right, so just remember, bring your student ID to the exam. And just on a similar note, make sure you know your ZID and ZPass. Make sure you can log into VLab and things like that, and make sure you can do it without panicking or without forgetting your ID. You won't be able to refer to a piece of paper or a phone in the exam, so make sure you can log in, right? All right, here's another sort of resource from the UNSW exams team. There's an exam preparation link and there's tips. So keep this in mind. This is important. It's important to study and prepare, but it's also important to make sure you actually try and get some sleep. Get yourself organized, like make sure you've got your ID card ready and things packed the night before so you're not rushing around in the morning. Make sure you know where you've got to get to, your exam location. I know that you don't know where that is yet, but you'll know it by mid next week. So make sure you're familiar with where it is. Leave in plenty of time. There might be traffic, Unfortunately, the exams team doesn't accept there was extra traffic and I was late as a reason for not getting to the exam on time. All right. And eat something decent. And eat something decent that, you're used to eating. Don't suddenly eat something weird or new. Or if you eat healthy, usually don't eat a big slice of chocolate cake that might make you feel sick. Try and eat something sensible. And all of these things do help if you do them. All right, now just a reminder, we're going to do some revision examples, but just a reminder of where you can find other study resources when you're studying for the exam. Well, there's the Week 8 lab test, which had some array hurdles and debug questions, and the full practice exam that's out in labs this week. So they're both available for you to try either again or try for the first time if you haven't done them. We're releasing more full practice papers this weekend. So after the assignments are due, we'll release some full practice papers, I think 2. So you're going to have at least, including that practice exam, 3 sort of full exams to sort of go through. We're doing practice questions today. We're not going to get through all of them. I've kind of made too many. So you can, 1, try these ones again, and 2, try the ones we didn't get up to. And try, I think, split folder from the previous week. The other thing is, I'm not sure if everybody knows about the extra challenges and revision questions. So these aren't in every week, but if we go to say week 7, for example, we've got our tutorial activities, our labs. We've also got extra revision content. So you can go and do some of these questions. They're very helpful. I recommend those. Even in the extra challenges, it sounds like challenge. Where is the week 8 practice exam? Good question. Tutors, do you know where the link is? I think it's available somewhere. But even with this extra challenges, it sounds like they might all be 3-dot questions. There are some 2-dot questions in there as well. So maybe have a look at those if you're looking for extra practice questions. All right. Other things are, you can redo your lab, like problem sets from the labs. You can try coding up some of the examples we did in lectures yourself. Okay. Okay, yeah, and here's the paper here. That's right. Okay. All right, so there's plenty of resources for you to practice questions, okay? All right, so we did some revision yesterday, and Tom did some array coding as well. That was good revision. So let's do some more. I'm going to start just with a debugging example just to get us all, our brains working. We've got some more hurdles we can do. We've got some sort of string and command line argument questions, a Kahoot. We'll see how we go. We'll see what people want to do. And we've got a Q&A with the tutors at the end. All right. But to start with, let's just do this one. This is one, it's really in the style of like a hurdle, but I've kind of purposely, like it's in the style of a 1-dot linked list hurdle, the question, but I've just done it and made lots of bugs that I really see again and again in hurdle questions. So let's see if we can debug it. So the code itself, when I show it to you, it's just you're given a linked list and you're trying to find the minimum value in the linked list. Okay, so in this case it's 2, and in the question it tells you if there's nothing in the linked list, just return -1. So it's sort of a 1-dot linked list sort of difficulty. You're basically trying to traverse the list, find the minimum. So I've already written it with some bugs on purpose. So let's just see if it compiles to start with. And, if it doesn't, of course. Is this big enough, the text? Can you see it properly? Let me know if it's too small and you can't see it properly. You can see it. Okay, good. All right. Okay, so can we see these error messages? How do we get it to compile? What have I done wrong here? Any suggestions? And if you see any other problems, let us know too. So basically we're just trying to debug this particular function. It's given a linked list. It's trying to return the smallest one. So the head of the linked list, imagine we do have some elements in there. It might be like this, and we're supposed to look through it and go, okay, that minimum would be 3. But can anyone see why it's not compiling? So over here, it's saying on line 20, we've got redefinition of min. On line 60, a previous definition is here. Well, we've got min, and min is a variable, and we've basically declared it twice. So up here, we've said, let's set min to -1. And here, we've declared another variable called min. So either they're supposed to be 2 different variables, or they're meant to be the same variable, but we shouldn't redeclare it. Okay, so yeah, remove int. Yep, so that's what we'll do. Get rid of that. Okay, now it compiles. Is that good news? I guess it is. but of course we know it doesn't mean it all works. 2436. Okay, nothing's happening. What do we need to do? So someone's talking about the null case, which is exactly right. We do need to consider that. What about this case where it's not null? It's not doing anything. Yeah, and I can see a good suggestion. So if we're doing this, this means we're stuck in a loop. And sometimes we might be stuck in a loop because, you know, in an array, maybe we haven't incremented a counter. In a linked list, maybe we have forgotten to move car to car next or something like that. Now in this case, we haven't forgotten it, but we've accidentally put it inside the if statement. And the number of times I see people that have accidentally done this in an exam, and maybe everything else is right, but in the exam they did it and they might have been too stressed or didn't have enough time to fix it. Yes, we need to move it to there. We should be very careful if we've got these sorts of things inside if statements, because if the if statement isn't true, we're stuck in an infinite loop. So I'm going to Control C it. And I've got to compile it again. Okay, so we're not getting an infinite loop anymore, but we're not getting the right answer. Let's also just check for now, just to see what's happening with this code. What if I do an empty list? Because somebody mentioned that. If I pass in an empty list, it's crashing. Now, if I'm passing in an empty list, let's just get rid of that. If I pass in an empty list, head is null, and I am checking for that, and I'm setting min to -1, which is what we like and what we want, but what am I doing wrong? Yeah, I'm doing something wrong because I'm still executing the rest of this code. And the rest of this code is going to crash, at least here, we'll have null, arrow, data. And if you're looking and seeing lots of things wrong with this code, that's true. Let's focus on this now. So it's telling us this is the line that's making it crash, and it's telling us, well, head was equal to null. So this is common too. We've got an if statement to handle this, but we've either got to wrap all of this up in an else statement, so it doesn't execute. So if head's null, we don't do any of this code. So that is one way we could handle this. Let's just check though. Yep. The other thing is, and sometimes this other way, if you've got more complicated code, can be a lot less work, especially in an exam. Yes, and somebody suggested it. We could just return this straight away here. If we do that, we're done. We don't have to worry anymore about the head being null. We're returning it and returning our answer straight away. So this is also a way we could do it. In an exam, do whichever one is nicer for you. Okay, so I think we've dealt with the null list. But now why are we getting the wrong answer? So all right, here's our list. Sometimes you can look through and see it. Sometimes you might really need to just spend a few minutes actually going through what's going on, because sometimes people just start randomly changing things, right? And that can actually break the code more. And maybe some of you can already see what's going on, but we're making car equal to head, which is great. Oh, but before that, we're initializing our minimum, which is what we're looking for, and we're going to the head and getting the data out, and we're saying min is 20. and that's fine. And we're setting char to the head, and then we're just checking if char next is null, and we're comparing the head to the min, and we're saying, well, 20 is not less than 20, let's move char on to here, okay? And we're back to the next loop. And then again, we're checking, well, the next one's not null, but again, we're checking this head data. We're checking 20 is less than 20. We're never actually checking the data inside all of these nodes. And this is also something you see a lot too. Sometimes people have accidentally always accessing head instead of char or something like that. They've just made a typo. So just look for those things as well. So here we were only ever looking at the data inside this first node because we kept writing head. All right. Hopefully this will, yeah, and people have already sort of saw that, some people, so very, very good. How's this helping us now? Where's my, okay, great, we got 3. Why is this easier than the practice exam? Because I already wrote this, but I just made it buggy to debug. But also, yeah, it is harder when you're doing it yourself. Yeah, and this is on the easier side, this question. All right, have I got it working though? Does this work? Do we think this works now? So it worked in this case. So imagine in the exam, you're gonna have a bunch of auto tests. Yeah, somebody's asking now, what if the smallest one was at the end? Is it gonna work now? Let's try this one. No. So whenever we're doing something like this, so Phantom, you're exactly right. What we're going to do is we're going to stop. We're going to look through here and we're going to say, okay, well, 4 was smaller than 20, 6 isn't. We get to this node here, the next one's null. We never go and look at that value 3 inside. We just stop here. We never go and say, okay, well, 3 is less than the minimum, so it's the minimum. We don't end up processing that node. And again, this is another really common thing that people use char next when they should be using char. So if we change this to char, it should work. Yay. All right, I think it does work now though. So there was actually quite a bit wrong. You can go back. Yeah, you were absolutely right, Phantom. You can go back and look in original files and try it yourself later. Okay, so that was just a little thing to get our heads sort of together. So I've got more examples. There's another debug string one that you can try yourself. And I might do some hurdles. So I'll show you 2 linked list hurdles. They both involve having 2 lists. So let me just change into the correct directory. Oh, I think I've already got these open. All right, so in this particular example, so sometimes in your linked list hurdles, you're going to be given 1 list to do something with. Sometimes you're given 2. And if it's a 1 dot, you're only really going to have to look through them. You're not going to have to, you know, modify the structure of them. But this one is a linked list of characters. It often doesn't really matter whether it's a character or an integer or whatever in our linked list, because it's the linked list and the pointers that's the difficult part. But in this one, we're basically just finding the difference in the number of nodes between these 2 lists. So basically we're given two lists. In this case, imagine we've got a list with 3 nodes, and a different one we've got a list with 5 nodes. And we just want to work out, well, there's a difference of 2 nodes between these two lists, right? One's got 3, one's got 5. So how do we write this sort of code? What are your ideas? Yes, and someone's saying count through each list. Now, this is an example of when we've got 2 lists that we can process independently. We can find the size of list 1. I'll just call it size. So imagine we write a function to find the size of our list. We could call that on the first list, then call it on the second list. There's no interaction between these two lists. We just go and find out how long they both are. And we've all sort of written this kind of code before, and you can always make functions in the exam, like helper functions. I know a lot of people have a tendency not to. So you don't have to. I usually like to. So if we're doing something like this, oops, and we've seen this before, so I won't spend too much time. We're just going to basically traverse the whole list from beginning to end. And we want to make sure we count that last node. So we're going right up to car is not equal to null. And each time we just increment our counter. All right, and we've seen this before. That's just going to count the number of nodes in our list. Basically, all this question is doing, you're given 2 lists. You've got to basically work out how many nodes are in each list and just return the difference. Okay, so if this list has 3 nodes and this list has 5 nodes, the difference between that is 2. Yeah, but we've got to do it so we can't return -2. We've got to do the absolute value. So we can process these lists independently. What's the length of the first list? We can write code very easily to do that. Well, not very easily, but for linked lists. We can find the size of the second list like this completely independently. And then we can just do the diff. So we can say, well, you know, length 1 minus length 2. And then we can return that difference. And I didn't put this star here. That compiles. And often when we're running these list questions, we type the things in on the command line argument, you know, if we're going to run it ourselves. Obviously, most of the time you'll be looking at auto tests. And typically when we run these linked list ones, if there's more than one list, we might put that dash in between to separate the list. So it's telling us this should return 2, and we're doing well. We've got -2. How are we going to do the absolute value? Yeah, we can either use if statements, or we can use, there's an absolute value function. Yeah, so if you know the absolute value function and you want to use it, you can. If you don't know it, then it's really easy to just do if statements as well. Beautiful. Otherwise you could, yeah, there's lots of options. You could say if diff is less than 0, diff equals -1 times diff or minus diff. There's lots of ways. We're not going to make questions that make you fail the exam because there was one function that you could have used that you didn't use. All right, so this one I think is not too bad, right? Now, just to compare, we've got another linked list question where we also get passed in 2 linked lists. And I might just delete this. Now, the lists might not be the same length. And we want to go through this. Oh, abs is from studlib.h. But don't worry, you can always write that yourself with some if statements if you don't remember it. But let's look at this question. We've got 2 linked lists again. And what we're trying to do is go through the lists and see how many of the values in the first linked list are equal to the corresponding values in the second linked list. So when we say corresponding values, let me draw these lists. It says 10. Oops. Actually, I will put this in. All right, you're given 2 lists and you're looking at the ones in the corresponding locations. So you're comparing this number here in this first location in the list to this one. Are they equal? No. Then we move on and we compare these 2 corresponding ones in the same positions. Are these equal? Yes. Are these 2 equal? Yes. Are these 2 equal? No. So this is what we mean when we say corresponding values or corresponding locations. All right, does that make sense? So basically these 2 nodes here that are in the same position within the lists, they both have 5, so we increment with our counter. These 2 both have 10, that's a match, we increment our counter. Now, we're not looking for things that are just equal anywhere. We're not saying, okay, well, this one here is a 1 and so is this, because they're not in the same corresponding locations. Okay, we're just going along looking at each node at a time within the 2 lists. Now, does that make sense, what we're trying to do? Now, with this particular example, there's no way to process the first list and then process the second list. We have to go through and compare each node in the list one by one. So it's not like the other one where you can do all the work on list 1, then all the work on the other list. So you're often going to see this, and actually Tom showed us an example yesterday where we had arrays where we were processing them at the same time as well. So we need to think about, and yeah, I think that's correct. I'm seeing some good things in the chat, but we need to think about when we're going to stop the loop. So we're probably going to have a current for each list that we're going to move along, right? Go one by one and comparing things. But as soon as one of these is null, we want to stop the loop, right? Otherwise, we're probably going to end up crashing something if we keep going when one of them's null. Now, when we finish though, if we stop our loop here, we've still got this node from that first list in this case that we haven't processed. Is that going to matter in this example? Does it matter what comes in this list, you know, past the end of the other list? No. Yeah, so if I'm at the end of this list, none of this list matters anymore, right? Because it can't match anything if the other list is finished. So in this case, We just have to traverse both lists at the same time. As soon as one of them's null, we're done. So I'm going to make a counter, and now you don't always have to make current pointers, but sometimes you do. So if you're not sure, just always make them. Oh, but give them different names. So I've got car 1 and car 2, and I can say while car 1 is not equal to null and car 2 is not equal to null. So they both have to not be equal to null for us to keep going. As soon as one of them's null, we finish. And like we saw yesterday, I think if we did or, we could still keep going when one of the lists is actually null, and that could probably cause us to crash. So for each one, right, our car 1 will be pointing to a node, our car 2 will be pointing to a node, and we're just comparing the values inside them. So we're basically saying, well, if car 1 has data at this position that's equal to car 2 at this position, then I'm incrementing my counter. Otherwise, I'm not doing anything, okay, except moving along, to the next. So I move car along, car 1 along, and car 2 along. Okay, and make sure you don't do typos and type car 1 instead of car 2 and stuff like that. Okay, so then we're just moving them along one by one, and we're just checking the contents. Yep, these are equal. We'd increment our counter. When we get to the end of one of them, we've got nothing more to do, and we return our counter. So this is just an example of where you do have to process the lists at the same time. Okay, let's just see if it works though. Oops. And let's do 1, 5, 10, 3, 2, 5, 10. Yay. What about if the other list is, oh no, I didn't want to do that. What about if this list is shorter? Yeah, it still looks okay. What if they've both got one value? No values. Like the auto test would most likely go through all of these different things for you for the 1-dot hurdle questions. But if you needed to run them yourselves, you could try it as well. All right, how do we feel about those 1-dot hurdles for the linked lists? Okay, now there's a bunch more that you can try yourself as practice. Easier than the practice exam. It might be. These particular examples might have been easier than the practice exam. Okay, now here's another one, array count. This is counting arrays and seeing whether they're odd. You know, again, the corresponding values. So this is very similar to what we just did with the linked lists, where you're processing each array at the same time and you're checking whether the ones in the corresponding values are odd, like the corresponding locations. So I might leave that one for you to try. Or do you want to do it? Oh, it's hard to ask you. Oh, let's do it. Let's do it together. Because, oh, okay, people, all right, I might leave it because it is similar. Think about this linked list one and try it. And we can do a 2-dot linked list delete duplicate problem. What's the time? Yeah, we've got time for this. And then we might do a Kahoot and have a break and then come back and do more coding. All right, now this one is 2-dot and this one is tricky. We're trying to delete the first instance of a duplicate in the given list. And the wording of this is quite ambiguous, but in an exam there'd be lots more clarifications and lots of examples. So basically we've got the value 1 here and there's a duplicate of that later in the list, so we delete it. And then we're done. There's a duplicate of 3, but the first one that we find is like the 1 and we delete the first duplicate of the 1. Hopefully that makes sense. So what we're trying to do with this is the way I would try and solve it is I would start with some sort of pointer to this first node, and then I would go through this list and see if I found that value again. And if I did, the first one I find I delete and I'm done. But you know, just say I had a different list. Like this, you know, oh no, not if I draw it the same way again. Okay, I'd be searching for this and I wouldn't find it. So then I'd have to move along to here and then search and find a 3. And if I do, then delete it. Okay, so there's kind of lots of ways to do it. Let's give it a go. All right. So let's draw it again. So I'm going to get rid of this. I want to try and delete the 3. So first of all, I'm going to create a current. And basically, I'm going to traverse this list from beginning to end and then look and see if there are duplicates. So let's just think about that part. I'm going to say struct node car equals head. And while car is not equal to null, I'm going to check if there is a duplicate of car data and delete it. Okay. And now I could write another function, or I can keep going in this same function, but that's how I'd think about it. Now, when I'm trying to check if there's a duplicate, I need to start checking from here, right? And I want to check from here to the end of that list. So now I want to have another kind of pointer. I can't call it current again. I can call it find or scan or duplicate check or something like that. I'm going to call it scan, but it's just like another car. You could call it car too, but just something that you won't confuse yourself with. And I only need it in this loop. Let me do it in here. And where am I setting this to be? Like, what am I initializing it to? So always just look at this in this scenario. I've got current here. I want to start looking through the all the nodes in the list starting from the one after it. Yeah, so I can initialize this to current next. Okay? Well, we're always starting at the beginning of the list. So if there were duplicates before, they would have already been found. So the duplicates are always going to come after because we're starting looking at the beginning. So I can do the same thing here. I can say, well, while scan is not equal to null, scan equals scan next. And that's going to be moving this pointer along. The only thing is we need to check if we find what we're looking for. So in this case, we won't. We'll come back to the beginning. And we wouldn't delete anything, but we do have to have the if statement in case. And what we're checking is the data inside current, right? I'm pointing to this node that has 1 in it in current or car. Is that equal to the one I'm currently looking at with my other pointer called scan? If it is, I want to delete it. Okay. Now in this case, I haven't found it, right? So current is 1, scan is 3. I'm going to end up moving scan along this whole list one by one. I'm never going to try and delete it. That's what that loop is going to do. And then my current will end up moving along. So in this example, I didn't delete the 1. I'm going to move current along to here. And that's current. Actually, I'll make it green so I don't confuse myself. And then I'll make scan next to current equal to current next again. And I check, is 3 equal to 5? No. I move this along to here. And I've found the 3 and I want to delete it because it's equal to the one that's in current. What's my problem? Yeah, we might need another pointer because there's no guarantee. Like there could be lots and lots of nodes in here. This list could be like size 100 and there could be hundreds of nodes between these two duplicates. So we're going to have to keep track of that previous node again. That's how I would do it. So instead of just having that scan thing, I'm going to call it previous scan. So when I set up my scanning node, I'm going to set it to current next. And the way we're doing it, the one before the scan one, it's always going to be the current node. We're never going to be deleting the first node in our list because the first node couldn't be the duplicate. There couldn't be something before it that matched it if it's the first node. So I'll be saying previous scan is here. Where current is, scan is here. And I'll be doing this whole thing we've done before. Is the current one, which is 3, equal to this one that scan is pointing to? No. So we'll move it along, but we'll also move the previous one along. So we'll say prev scan equals scan. And then we'll say, oops, where's my mouse? And then we'll say scan equals scan next. Okay, so we've seen this kind of thing before. It's just that now we've also got this extra pointer happening. So when we do find it, Normally previous would be null, but normally we're scanning from the beginning of the list. Here we're never scanning from the beginning of the list because we're always starting one after some node that we're looking for a duplicate from, right? We don't have to start searching for these duplicates from the beginning. We're always scanning from one after the current, which makes the current, sorry, I need some drink. So just quickly, even when we start off, if we've got a list with 1 in it and we're checking for duplicates, we're checking in this part of the list. So our current would be here. There's nothing, we don't start from the beginning. We're checking in these nodes. So we're never right at the beginning of the list when we're scanning through looking for the duplicates. So that's right. Previous scan starts off as current and then it moves along tracking behind scan. So by the time we find this thing that does match, here and here, we do have that previous node in there. The one that's before scan, right? Because then what we can do, and this is good because we're never going to be deleting from the first node in the list. Prev is never going to be null. So we can just say prev scan next. So basically what we want to do is connect this one here. Oops. This one here to the next one here. In this case, that next one's null. That's fine. You can make something equal to null. Other cases it mightn't be. So you'd say the one after prev scan should be the one that's currently after scan. Whoops. Right? We want to connect. This is the thing we want to delete. We want to connect the one before it to the one after it. And then we just want to free this. What's this called? Okay, we already have had enough variables to make sure we could free it properly. Now, in this example, we're lucky because we just have to delete one thing or nothing. So once we've deleted it, we can return from the whole function. And that's what I'd sort of recommend here, because it's hard if we're in the middle of two loops. We'd have to have lots of lots of flags if we didn't return, and it would probably be quite messy. So in this function, when we're done, we just return the head of the list. Okay. Even though, to be honest, we're never going to be modifying the head of this list. And also a word of warning, don't do what I nearly just did there. In a lot of the code you're given, you might have a return null at the end. Don't forget to change it to what it should be. So I think this works. Now again, if you were sitting there doing this on your own, you really do have to think about what you're going to do. And you might not do it exactly like this. And we don't even know if this works yet, right? Okay, so I've done my usual trick, which is I've called things car in some places and current in the other. And I've left off a semicolon. Okay. So let's try 1, 3, 5, 3, 1. It should delete the ones. Yeah, the 1. Let's see if we wanted to delete not at the end. Yep, we deleted a 3. Does it work if we've just got one thing in our list? It does. Nothing in our list. Okay, I think it works. Why do we have to return head inside the while loop and not only in the end after traversing through the whole list? Well, we only want to delete the first thing. So just say our list has head 1, 3, 1, 5, 1. We only want to delete this. We don't actually want to keep going. So we want to make sure we don't keep going through all these loops and deleting more. So the way around it, you could have some sort of variable that says, should we keep going? And you could be checking for that in your loops. But the easiest thing is, I've deleted this. I don't need to do any more. I'm just going to return. If we wanted to delete all instances, we would have to keep going, and we would have to think very carefully about what we did after this. Like we did before, we have to work out where we want prev scan to be and where we want scan to be. So if we wanted it to delete multiple, so imagine, let me try and go back to my beautiful diagram. Oh no, I'll just draw it again. It was messy. So I've got, imagine I've got something like this, and current is here, and imagine I do find something here to delete, and my previous scan is here. I'm connecting previous scan to scan next, and then I'm freeing this. So instead of returning this now, and I'd want to put this in an else. I'd be now wanting to move scan to here. How do I access that now? I can't say scan next because I've freed this. I would call this scan equals prev scan next, right? This would, I would have freed this, and I move scan to the one after the previous one now. And then previous is in the right spot. Does that make sense? So I've freed this. I'd already hooked up this, I'd already hooked this node up to here. And then I just want this one to be after this one again. And then I could keep going in this loop, right? And if I'd keep moving previous along and scan along, previous along and scan along, and I'd delete that at some point. And then I would then move this current along and look for all the duplicates of 3. Let's see if that works. I'm not 100% sure it will. One, 3. Okay, so that deleted all the ones, but what if we've got and it deleted all those. What if everything in the list is a 1? Yay! Yeah, so that's getting quite complicated, I think. So if you found that difficult, don't worry. That is a tough one, especially if we've extended it like this. But again, if you did it yourself, you might do it a completely different way that makes more sense in your brain. Let's have a quick break, and I'll do a poll. So in the poll, we've already done the linked list hurdles, so there's no more linked list hurdles, Rosemary, but put the other things in the poll. But we'll come back in about 10 minutes. Okay, welcome back from the break. So the winner of the poll was array 2 hurdle followed by revision Kahoot. So we'll definitely do the 2 array hurdle. And we'll see if we've got time for the revision Kahoot as well. We'll see how we go. So there's a few more linked list hurdle examples you can try for yourself. Let's have a look at this one. Now, sometimes for array hurdles, for these 2 array hurdles, sometimes you'll have to write a whole program and not just a function. So this is one of those examples. And sometimes you do have to do your own input, you know, like scanf, %d and stuff like that. So here we're reading in from a terminal, but we're stopping. If we get a number entered when multiplied by another, this sounds confusing when we read it, multiplied by another number previously entered results in 56. So in this example, the person types in 2, like just, you know, and we're reading it in with scanf, and there's no previous input. The person types in 3, and we've got to go and check, well, in all the previous input, if we multiply it by this new number 3, do I get 52? So we check, is 2 times 3 equal to 56? No. So we keep going. We get a 28. We go through all the previous input. We see, well, is 2 times 28 equal to 56? Yes, it is. We stop and we print this out. Okay, so there might be a whole heap of input before we get to something that multiplied together gives us 56. Right, and we'd be, when I type in 87, would be looking at, well, does 1 times 87 equal 56? No. Does 2 times 87 equal 56? No. Does 9 times 87 equal 56? No. Does 100 times 87 equal 56? No. So we'd keep going. Does that make sense what we're trying to do? So we read something in, we can compare it. Oh, right, no. Terminal is like just when we're typing stuff in and using fgets for string or scanf for everything else. Right. So the first thing we're basically doing is we've got to write our whole thing, right? Int main void. And if you did forget that, you would have enough other code to look at to remind yourself available to you. But yeah, the first thing we want is we're going to need to store these numbers somewhere, because if I need to go back and look through all those previous values and see if I can multiply this new number by any of those values, I've got to make sure I've stored them somewhere. So basically, one step to this is just, can I even enter all of these numbers into an array? So let's make our array. I'm just going to call it numbers. And we're given a max size, and I think we're guaranteed that, you know, we're never going to have to store any more than this. And now let's just do a normal scanf loop, right? If I wanted to read integers in to somewhere, I would do something like this. Now, in this case, I've got an array. And I'm going to need some sort of counter to keep track of where I'm putting them into. So, I mean, we could call it I. Or counter, or something like that. I'm going to call it I. It's probably not the greatest name. But I is going to start at 0. So the first number that we enter, like imagine we type in 99, that will end up going in position 0. So to do this, you know, we've got an array called numbers. We're putting it in at position I. And of course, this is scanf. We've got to use the address of that individual location in the array. Okay? And then after I've done that, I would increment I. Right? So let's forget about the rest of the logic. This would just be allowing me to increment I and read the next number into the next cell of the array. Right? Increment I, read the next number into here, etc. All right. So right now we're not checking anything, but just say we do check something. So imagine when we've just typed in 99, we're trying to look at all the previous data, and there is no previous data. All right. So let's think about when I is equal to 1 and we're putting the 4 in here. What we want to do is go and look at all of this previous data. So right now I is equal to 1. We want to look at all the data from index 0 up to I. And in this case, that would just be from 0 up to 0. And we're going to check whether the ones in any of those pieces of data before us multiply by us and give us 56. And let's just keep going a little bit further before we start coding it. Next time round, I will be equal to 2, and we'll be typing in 7. And we'll have a loop that goes from 0 up to I, and we check, is the one at index 0 times this one at I equal to 56? No. What about this next one? No, etc. So we're actually going to need another loop that looks through all previous values. So that loop is really just going to start, and we can't call everything I. It would be better if we had better names for this. Maybe prev is confusing for you all though. Okay. I'm going to call it data index because it's getting too long. And I'll just move this. So imagine I've just read in, so I is equal to 2, and I've just read in the number 7. This is going to look through indexes from 0 up to index 2, but not including it. And we're just going to check. If I go to my array, which I've called numbers, at one of those previous indexes, and I multiply it by this number that I just read in, which is at index I, does that equal to 56? Or does that equal 56? If it does, what do I want to do? If it does, then I've found it. And I want to make sure I print out the correct message, which would be basically the number I read in multiplied by some other value equals 56. So the number I read in is numbers at index I. The previous value that I've matched and just found was at this index, and I go and print that out. What do I want to do now if I've found it? Yeah, I can just finish the whole program. This is good. I can just return 0 and I'm done. Okay. Does this look like it works? So in this case, you know, we've typed in 7. I should be, data index should be going from 0 up to less than index 2. So it'll be checking 99 times 7, 4 times 7. It shouldn't work. So then we're going to go and scan through another number. And then we get 56. When we get our 56, I will be 3. But this loop will start at 0 and go up to 3, but less than 3. So it'll be checking, oh, I forgot to type in a 1. Let's imagine that right here was a 1. It's going to go back to index 0, the way we've coded it. Now, if you wanted to look backwards, that is fine. But we're coding it like this, and we're going, well, does 99 multiplied by 56 equal 56? No. What about 4 multiplied by 56? No. What about 1 multiplied by 56? Yes. So we're going to stop the whole program at this point. Let's check it. Now, in the exam, you'd have you'd have so many examples showing you all the different behavior that it would hopefully be clearer than me just sort of explaining it verbally. Okay, so it's waiting for me to type stuff in, this scanf, and I'm typing in 99. And as it reads it in, it's going to check from 0 up to less than 0. So it's not going to do this loop, right, for 99. But when we get to 4, it's going to go through and check, well, what about 99 times 4? When we type in this 1, it's going to check, well, what's 99 multiplied by 1? What's 4 multiplied by 1? 7, it's going to check 99 multiplied by 7, 4 multiplied by 7, 1 multiplied by 7. 56, it's going to go back and multiply by 99, then 4, then 1, and then it should work out that 1 times 56 is 56, and it should stop. Okay, so this is the other sort of style of 2-dot questions that you could expect, where you write basically a whole program. And again, I've included another one that you can go and have a look at and try yourself. This time, it's just reading integers from standard input until it gets a negative number. That's what stops the loop. Then after the loop stops, it is printing the odd numbers and then the even numbers. So you can go try that. That's another one where you basically write the whole program and you read in the data. For other types of 2-dot array hurdles, we did one the other day. It was a 2D array. So that's another common possibility. There's also this one, and in all honesty, I think this one is a little bit more than 2-dot. So if you try this one, I think it's on a bit too hard side for a 2-dot array hurdle. But it's a good practice if you want to go, you know, just for other questions. So I've left it in there. All right. There are also, so it does explain it more in the file, but this is basically, contiguous just means right next to each other. So if I've got an array 5, 1, 6, 7, you know, this whole thing is a subarray. So is this. This is a subarray. This is another subarray. We've got all these different subarrays of different sizes. And then we can have ones that just go from here and here. So it's just parts of the array that are next to each other. So you're not going to have a subarray that has the 5 and the 7 because they're not next to each other. But you could have 5, 1, 6. They're all next to each other. All of these files, for all of these questions are available. Let me show you where. So if we go to week 10 lecture code, gosh, there should probably be a lot here. There's all the linked, there's all the different hurdles. Now, these are the ones we either went through in class or we potentially were going to go through in class. Then in the self-study ones, there were ones I was never going to go through in class. I've just put them there for you to try. And some of them have slides that talk about them a little bit. And they've got, yeah. So you can go through, you can redo the ones we did or the ones we missed out or the ones I just gave you to use for self-study. So there's a whole bunch of them. And if you have any questions, ask on the forum in case you're trying to do them and you do have a question. We are going to have, I don't think we do have time for a Kahoot. Actually, I think, all right, let's try it. Let's just start. It's only a quick one. So let's join, everyone join the Kahoot if you don't mind. All right. Okay, let's start because we don't have too much time. Excellent. So that's the answer, but I think a lot of people got it right. Well done. That's just to get your brain going a little bit. And this one's to torture, torture us all, right? Oh, you can't hear Kahoot music. Okay, just quickly, we start with i's equal to 9. So as soon as we see this, we know we're going to index 10. So it's going to be a runtime error. Okay. All right, I'm going to join. In a minute, we're getting the tutors on. So I'm just going to leave this for now. Let's get rid of that. And we'll just quickly finish this Kahoot. All right. Oops. Okay, with this one, basically, we don't have much time to go through it. This was a bad idea. This pointer is pointing to A. So when we make it equal to B, we're saying A is equal to 20, basically. Alrighty. Okay, sorry, tutors, we'll be there in about 3 minutes. Okay, so be wary. If your string is too long, it's not going to fit when you do your string copy. So there's not enough room in the first string to fit the second string over the top of it when we string copy. So it's going to crash. Yay, very good. All right, let's move on. Okay, this is the classic example of we're trying to count how many nodes are in the list, but we're stopping at current next, so we don't end up counting the last one. Okay, so we end up with 4. All right. Okay, so this is the same code as before. Because we've got current next is not equal to null, this is going to crash if we've got nothing in our list. If we do have a list though, it's not going to crash, but if we were trying to find the number of nodes in the list like we were in the last question, well, I'm assuming we were trying to do that, then we're going to miss out on that last node. So if we've got 5 nodes in the list, it's going to tell us that there's 4 if we only go up to this current next instead of current. So sometimes it is what you want to do, but in that last one, we were counting up to all the nodes, but not including the last one. All right, how are we going? Joyful Otter's doing well. This question's mean. And then we're going to go ask the tutors some questions. Wow, people got it right. It wasn't so mean. A lot of people got it right. Basically, we're just passing in one element. We're passing in 0, 1, the 1 at this particular index, and that's what we're changing. Okay, so it'll be equal to 6. All right, there's one last question. You're all going to get this one right. Unless you refuse to answer it, I guess. Time out. Yay! You all got it right. All right. Thank you, everybody. Well done for winning the Kahoot, or getting a place, or just even doing it. I know I went through it very quickly. Well done, Wondrous Koala, and everyone else. I don't even know how to give you chocolates if you won. You can go and ask at the exam. Come up and see us and get chocolates at the end. All right, thank you so much. Hang around. As soon as I can get out of this, why can't I leave it? Escape. Meh. Why can't I leave this? Ah, here we go. Okay. All right. Okay, hello tutors. Now let me try and change my view. I've already forgotten where it is, right? View, together mode. Together mode. Sorry, I was going to do this on the other screen, but it's popping up on both. Yay. So everyone, please welcome. We've got Sophia. I'm trying to point with my hands, but I realize that makes no sense here. Sophia and Grace, who's both of our lovely admins and tutors. And we've got Liam, who you probably see each week if you come to in-person lectures. He's our wonderful cameraman, and a tutor as well. They're all tutors. And we've got Rosemary, who's manning the chat. Well, that's a bad word, isn't it? Looking at the chat. All right. So this is your chance to ask the tutors different things, but also just while we're waiting for you to ask questions, I don't know, do we have any exam tips or any words of wisdom for our amazing students in this last week? Sophia.
Oh, on the hot seat first. Okay. Exam tip. My biggest tip would be...
Can I just check? Sorry, can everyone hear us properly? Can everyone hear the tutors?
Hello.
I think they can. I think they can.
Same thing.
Oh, it's a bit quiet.
Oh.
Is everyone a bit quiet?
Is it better now or not really? Speak, Sophia.
What a helpful lecture. Yes.
I don't know. Is it still too quiet?
on OBS on your OBS?
It looks like it's okay.
Oh,
Yeah, I'm not sure. Keep talking. So I can
okay, sweet. Was it my best tip for the exams? Yeah, right. I think if you like study and everything, obviously, but when you're actually in the exam, I think just focus on smashing out those hurdle questions, and then just really remember, like, mental shift that the rest is just for marks. So like put that pressure off yourself and know that, like, you know, once you've cleared the hurdles, the rest is just for marks, and that's all you're trying to do. So try and, like, yeah, take some of that pressure off. Yeah, can be stressful, but that would be my tip.
Okay, just
Great.
wait a second. I haven't got the sound set up properly. I'm trying to make the YouTube, for some reason, isn't getting it from. I'm trying to get it directly. Hang on.
I think in OBS it would be your computer input volume, or your computer speakers,
Yep.
and just blast that out. My headphones are going into the background.
Is that? Can you hear them now?
Hello.
Hi.
Hello.
Oh no.
No? It's a bit better. Okay. I wonder if you can hear me now. Might not be that important if you can or not. Okay, good. All right. Sophia, can you say that wonderful answer again? And if you've got any questions other than how can I hear you better? Okay, it's good now.
Yes.
Excellent. All right.
Yeah, my tip was to obviously try and clear the hurdle first, and then as soon as you've done that, just remember that the rest is full marks. So like take that pressure off yourself and just go for it, and just try what you can do. Time box and move on if you can't solve a question, and just go for it.
Mhm.
Grace?
Mine would probably be like we will be releasing some more practice exams at the end of this week, I think. So my recommendation would be try to sit one of those, like try, study the topics maybe you're less comfortable with, come on to a help session, but like try sit the practice exam under exam conditions. So limit yourself so that you're not using AI, you're not, relying on anything else. You're just using the course website and see how you go under those conditions, because that'll be exactly what you're doing for the final exam. So hopefully sitting under exam conditions will make you a little bit less nervous about doing it in an exam environment and just give you a good feel for it all. So practice with the papers we give you.
Yeah,
they're very good questions.
That is excellent advice. Liam?
I think, yeah, both Sophia and Grace, I agree with it entirely. You can also look at the extra revision questions for some of the weeks. I don't think they're there for all the weeks, but there's also challenge exercises. So you can like use those to target any specific topics that you're weak with. And I really agree with what Grace said about like sitting under exam conditions. Like sometimes you'll forget like standard input output at the top of your file, and then you would be debugging an exam. Like if you're just going to blank C file. So really trying to simulate the exam conditions as best you can, like really helps, I reckon.
Yeah. And that reminds me as well, there are revision sessions next week, right?
Yes, I will be announcing them later this week. They're not up there yet, but they will be soon.
And there's still some more help sessions this week for people juggling the assignment and exams and everything. Does anyone have any questions for the tutors? No? Oh, is there any role to work in COMP1511 without directly teaching students like tutors?
I mean, you can be a lab assist, which is still somewhat teaching and explaining problems, but like not taking a tutorial. And yeah, I think most roles would include teaching to some capacity. So maybe not completely removed, but if you're nervous about teaching or it's something that scares you, you can always see how you go with the lab assist think it's something that seems daunting, but you know, once you do it, it's quite enjoyable. It's quite fun to teach students. So yeah, at least that was my experience.
Yeah, so that I think that's a good point. If you don't want to stand up in front of the class, it can be helpful to go to the labs. And once you're a lab assist, you can help out on forums and stuff like that as well. We've got and just in terms of that, there's a few questions. Are there help sessions? So there's definitely help sessions on, lots of help sessions on for the rest of the week because it's going to be quite busy. But there'll also be some help sessions on next week. I don't know if the times are up for those yet, but there will be some. There won't be as many help sessions next week in week 11 as there are this week, but there will be some. So keep your eyes out on that.
We'll make an announcement.
Yeah, we'll make an announcement. How long? Yeah, any suggestions for how long each question should take? I'm imagining in the exam.
I think that's really hard. I think it depends on the person. I think we can't really give you a time for each question per se, because sometimes things will just click or it might not. I would say that we do not expect you to complete the whole exam. It's very common for students to finish the exam somewhere between Q4 and Q8. So like somewhere in the debuggings or somewhere in the hurdles. Not many students get to those Q9, 10, and 11. So maybe you do just want to try and attack those like first 8 questions and then divide that by 3 hours and kind of see where that lands you. But it is all relative to how you've been going in the term, and I guess how long it takes you to take a lab activity, like a 1 or 2 dot, is maybe how long you can expect a question to take you in the exam. But obviously you have a bit of exam pressure, so it might be a little bit longer.
Yeah, and or I mean, it depends what you're like in exams as well, though. And hopefully by doing these practice exams, you're going to get a good feeling or some feeling for how long it should be. So if you're looking to get a solid pass in the course, you're going to spend maybe more time on those earlier questions than if you're really trying to get 100 out of 100. I mean, don't aim for that, but you know what I mean. You're going to have to whiz through some stuff if you really want to get 100 out of 100. Has anyone ever got 100? I don't know that anyone.
Yes.
But very, very rarely, if ever. So that
very rare.
should definitely not be anybody's benchmark for anything. All right.
I don't think we've had it in the last few terms, at least. Yeah, no, it's not a very uncommon occurrence.
Yeah,
I think.
Yeah.
I think another thing as well with the exam is that you don't have to take it linearly. Like you don't have to go question 1 onwards. You can start with the 2 dot hurdles. You can start with the debugging ones if you want to just like sort of ease into it a little bit. There's really no issues with just going whatever pace you want to.
Also, sometimes jumping, like, even if you are looking at the hurdle first and then you get a bit stuck, sometimes going and looking at a debugging question and, you know, doing through that, like, helps jog the memory. Like, at least if you're just, like, clearing your mind for a second and then coming back to the question, it helps to have, like, mildly fresh set of eyes.
Yeah.
But I also think in terms of the, like, how long should each question take, even though there are 11 questions, the 4 hurdles make up half of the marks for the paper. So they are where most of the marks come from. So it's okay to be spending a bit longer on those because they're also the hurdle requirements for the course. So I think, which is what Sophie said earlier, like prioritizing those is not a bad thing at all. It's a good thing.
Yeah, that's a good point. Somebody's asking if do we have any cheeky hints at one of the questions in the exam?
My lips are sealed.
There will be arrays and linked list questions.
Oh, don't give it away, Liam.
That's right. There'll be her, and there'll be some debugging. I think because we do give you quite a few practice exams, I think they're good hints at the types of things you're going to be able to expect. And I think for the sort of 1 dot and even 2 dot hurdles, I don't think you're going to get any question and think, oh my goodness, where did that come from? What on earth is happening? Why are they doing this to me? This is a very important question. So I'll get you all to reiterate this one. Is there a style mark in the exam? Is passing all the auto tests meaning full marks in the question?
No. No.
Yeah,
I don't know why we
would
were
say
grinning about that, but no.
in terms of style for the exam questions, style is not marked at all. However, if your code does not pass all of the tests that are run both in the exam, so the ones we give you, and the extra ones that we run while marking, if it fails any of those, your code is manually marked by one of us, which means that if we need to mark your code, we need to be able to read and understand what you've tried to do. So the basics of style, like indentation, some white space, hopefully some at least decent variable naming, is all helpful for us to be able to understand what you're trying to do and best assess the logic that you've put into the question. But it's not explicitly style marked. It just needs to be readable.
The thing as well is that like we teach style for a reason, and it will genuinely help you do the question better and debug better if you have good style. And like you can make functions, they are so helpful. We don't just teach them to take marks off in assignments. Like they're so important to use. And in the exam, it's really helpful, especially if like a big question, if you just want to make a little helper function.
To help break down some of the logic as well, yeah.
I think the second part is also really important. Auto test meaning full marks. So auto tests do not directly translate to marks awarded. They are indication of correct performance, that you are on the right track. But sometimes there might be cases where maybe you're hard coding or doing something a little bit dodgy to pass the auto tests, which means that when we go and manual mark your code, it might be revealed that you're not quite on the right track. But if you're passing auto tests, maybe not all of them, but you're passing a good chunk and you've given the question a good try, it is an indication of correct progress to a solution, which is what we look for when we're manual marking. We aim to award as many marks as possible for like correct pieces of code, correct logic and progress, but there is no guarantee that passing auto tests will result in full marks or a hurdle pass.
Yeah, or any particular mark at all. Yeah.
Yes.
Yes, very good question. Can't see any more questions. Do we have any other hints and tips?
The week 9 tutorial had a bunch of extra linked list questions, and I will let you know that when we were writing that tutorial, some of those were pulled from past exam questions. So that might be a good place to look for some extra linked list hurdles, and also the week 10 tutorial, some of those later questions were also past hurdle questions if you're looking for more.
Yep.
So,
also labs as well, like the labs that you've completed earlier in the term. I mean, I remember when I did the course, I just looked through all the labs I've done, and I just forgot how to do so many of the earlier weeks, and I found it really helpful.
Okay. Yeah. Any other questions before we go? Anyone have any, I don't know, other things, any tips for getting the assignment ready? Although possibly a lot of people finishing up the assignment aren't here right now. I don't know.
Sure.
Look at your assignment 1 feedback and look at your style feedback and make sure you understand it and try not to make the same mistakes, because style marks are arguably the easiest marks you're going to get in the assignment, and it's 20%, so it's worth quite a bit. So look at your feedback and improve. That's how you learn.
Also, yeah, it is the exact same rubric that you're marked against for assignment 1 and assignment 2. So if you lost some marks somewhere in assignment 1 and then don't change, you're probably going to lose those same marks again, because we're marking the exact same rubric. So have a look.
Ask in a help session, or ask your tutor in the lab if you haven't had it this week. Ask them why if you're not sure of why. So somebody's saying thanks for being such an amazing tutor, Liam. Somebody's just written this in the chat. So yes. So yeah, I also want to thank you all for being amazing tutors, and also admins, and lecture tech support, phone maintenance, support worker.
Let's cut the line next time. We'll know that.
Oh, my dear me. And moderator and stuff like that. So thank you so much. Thank you, Rosemary, who's busily looking at the chat. And yeah, thanks to all the other tutors as well. We've got such a great team of tutors. So I hope you've appreciated all of their hard work. And yeah, I think just good luck to everybody. There's still more help sessions. We'll announce them. There's still more support on the forums. And yeah, we're here to help.
Yeah, all the way up until exam day. The forum will have moderators as well if you can't catch a help session.
Okay, yes. And then on the day of the exam, we will turn the forum off.
Yes.
And we can't help you in the middle of the exam with any of the material. But up until that moment, we're here to help. Thank you.
And make sure to double check your exam time as well and check your allocations.
Yes.
Double check.
If you're the morning or afternoon exam.
Yeah, make sure you know where you're going and you're not running around lost and panicking. I have done that. I've done that as a student, not known, had a good idea where the room was.
Rock up early. Trains and light rails get delayed.
Exactly.
Rock up early.
Leave plenty of room. Do not get to the exam at the minute it starts.
Especially afternoon because corralling. So.
Yeah. As soon as the doors are locked, that's it.
Yeah, unfortunately, the exams team aren't going to sort of go, oh no, that's a shame you slept in. That's fine. If you're late, if you're too late, unfortunately, you may not you won't get let into the exam. So be very careful. The allocations will be emailed to you probably by mid next week with your exact time and location. No, you cannot fetch. So when you log into you're saying, can I fetch all the class code demo directory to my VLab directory? Can they just do a copy minus R of the code?
Yeah, I can give them a command to a direct path. I'll pop it in the chat.
Yeah, pop it in the chat. So
I don't want to mess it up though. Give me one moment.
and yeah, thanks everybody for turning up and interacting and engaging in lectures and also Tutor and Labs as well. I hope you all do really well, and I hope you learnt some stuff in the course this term. All right.
Thank you, Angela.
You keep the chat alive for 2
Oh,
weeks.
yeah, we've got to keep the chat alive so really we can answer that question. Thanks, everybody. Have a great night. I hope, again, that you're all going to have something nice for dinner. That's what I'm usually thinking about by the time the lecture's ending.
It is a late lecture.
Yeah.
It'll be ending at 6 p.m.
Thanks, everybody. Bye-bye.
Good luck for your exams. Yeah. You've got this.
Yep.
Don't stress too much. If you are stressing, email us.
Yes.
We can help.
We will help you. I can't find it. What's the path? Sorry, one moment, everybody. I'm working hard over here.
That's okay. That's okay.
It on my own before I give them a path. Oh, perfect. So you can go cp-r this to there. There you go. Run that copy command and you can get all of Angela's lecture code for the whole term into your CSE directory.
That's very scary. Okay.
Cool. That was under pressure.
if you're good. Thanks, everybody. I'm waving at the wrong place, I think, but goodbye. Thanks for coming, you guys, and see you later.
Bye.
Bye.
Bye.